All right. I said in class Monday, math is not magic. It's anything but. It's the exact same rules applied in different situations over and over and over again. So, here's the general quadratic. ax squared plus bx plus c equals 0. This can be solved in one of two ways. One way works sometimes, the other way always works. So factoring. Factoring is a special case when it just so happens that these numbers have a relationship that you can rewrite all of this addition as multiplication. That's why we call it factoring. When you rewrite 24 as 6 times 4, we say 6 and 4 are factors because you've rewritten this number as multiplication. So in the special case that this factors as the product of two binomials, it's pretty easy to solve. If it doesn't factor, there's only one way to solve it. And the way you solve a quadratic that doesn't factor is you complete the square. The way you complete the square is you start by grouping these terms together. ax squared plus bx plus c equals 0. Now, because it's an equation that we're trying to solve, I'm going to move this c to the other side. Subtract c, subtract c. Now I have the equation. ax squared plus bx equals negative c. I mentioned it in the worksheet video, but you may not have watched it. It is very hard to complete the square with this number here. So I'm going to make my life really easy, and I'm going to pull that number out, whatever it is, by factoring out an a. So what's left inside here is x squared. I factored out the a. What would be right here is a number such that if I multiplied by a, I would get bx. So that would be b divided by a times x. Good? Multiply a times this. ab divided by a. You get b times x. Good? All right. Now, inside this parenthesis, we are going to complete the square. The way you complete the square is you take half of this number. What is half of that number? Well, it's 1/2 times b over a, which equals b over 2a. That's not a coincidence. You've seen that before. The reason you've seen that before is because of this algebra that we're doing. This number you square, and when you square that number, you get b squared over 2a squared in parentheses, which is 4a squared. We're going to add that number inside this parenthesis. But now because we're working on two sides of an equation, if I add something on this side, I have to add it to the other side. Be careful. Algebraically, I didn't add b squared over 4a squared. I added b squared over 4a squared times a. That a would cancel with that, one of those. What I really added on this side was b squared over 4a. Okay, let me clean this up. Let me see where we're at. We should have, if we clean up what I just written, a times x squared plus b over ax plus b squared over 4a squared equals b squared over 4a plus c. Now, if you're not recognizing some things yet, take a look there. You should see some familiar stuff. Remember, Why is this a b squared over 4a and this is a b squared over 4a squared? Because I'm actually multiplying by a, so I have to distribute that a to see what I really add. Now, I'm going to get a common denominator over here. This is over 1. To get a common denominator, it would be 4a. I'm going to multiply by 4a over 4a. Good. I now have a times x plus b over 2a quantity squared. Remember, the whole reason we did this messy algebra was so that this would factor to a perfect square. That equals b squared minus 4 times a times c. I think that's a mistake there. I'm sorry. That should have been a minus sign. That should have been a minus sign. All over 4a. Okay, now we solve. We're trying to solve for x. I need to get rid of this number a, so I multiply by 1 over a. I multiply by 1 over a. No, those can't cancel because I have to do this math first. So I end up getting these a's canceling. I'm left with, on the left-hand side, x plus b over 2a quantity squared equals b squared minus 4ac, that whole mess, over 4a squared. I need to get rid of this square. I take the square root. I take the square root. But I got to remember the plus minus in front. So now I'm at x plus b over 2a equals plus or minus the square root of that numerator, b squared minus 4ac, divided by the square root of the denominator, the square root of a fraction. The square root of a over b is equal to the square root of a divided by the square root of b. The reason I'm splitting it is this denominator I can actually take the square root of. The square root of 4 is 2. The square root of a squared is a. Now I move this over to the other side and I get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. We usually write it all over one denominator because those are the same. The quadratic formula is not magic. The quadratic formula is every single algebraic step that would be necessary to solve the original equation by completing the square. It's a shortcut, but it's not magic. The way you solve a quadratic that doesn't factor is you have to complete the square. If you want to jump to the quadratic formula because it's quick and efficient, that's fine, but you need to understand the algebra that produced the quadratic formula.